Welcome everyone to the first ARCI virtual forum of 2023. It's also number 23 of our series of virtual forums, and I'm glad to be here moderating these. This is a lot of fun and very educational. I'm Tom Zaczek, and I'll be your moderator today. And I'd like to thank all the people from all over the country and other clubs that join in on these virtual forums. It's a great opportunity to learn stuff and to meet with other people. So thanks to everyone who has tuned in today. We have 4 more virtual forums planned for the year, as you can see there. And if you have any ideas or comments, you can always send us an email at that email address right there. So I'd like everyone to consider being a presenter or doing a show and tell. And if you have an idea for a presentation, just send us an email or give us a call. We can help you get one put on for the virtual forum. So protocol is very simple. We get a prearranged time for the presentations. I help move the meeting along and keep time and all that. And if you're not asking a question, just stay on mute. And we do record these, and they get put on YouTube and onto ARCI's video channel on YouTube. And there's quite a number of them out there now, 22 of them. And we're putting together an index so you can more easily find a particular presentation. And we're working on that. So to say a little bit more about YouTube and recording, I'll turn it over to Matt.
First thing I want to let you know is that YouTube has something called a handle, which for all intents and purposes is a new link. And this one, we could pick it. And so this is the link to our YouTube channel. The old link still works, but this one's a lot easier to remember. Second, the usual stuff. I'll keep it short. Be aware of copyrighted materials in your presentation, mainly music. So when you're demoing a radio, keep it off a music station. And 2, put confidential stuff in the chat. That's it.
Okay, Matt's going to put up a poll about whether you have a show and tell for later today after we do the presentation. So Matt, you put that poll up. I'll get the agenda slide up and we'll get going. So we've got a great set of presentations today. It's going to be very informative and fascinating stuff. And our first presenter, Robert Lozier, I think has done more presentations for the forum than anyone else, and he never ceases to inform and entertain and fascinate with his topics. And this one will be no different. This is about some stuff that I had no knowledge of, and it's just very entertaining and interesting. So, Robert, I'm going to turn it over to you.
So I've recorded the narrative on this. I'm going to run 25 minutes and 51 seconds.
Говорит Москва.
A radio broadcast receiving solution for a very different nation from ours. There was a problem before the 1970s. Vast areas of the USSR were without electrical power distribution. From the 1930s, the government wanted all citizens to be able to receive state radio broadcasting, either by local radio receivers or via wired systems of loudspeakers driven by neighborhood and apartment block central receivers. In fact, these wired speaker systems serviced more citizens before 1953 than via individual receivers in homes or workplaces. As you might imagine, the objectives were to indoctrinate Soviet citizens about the USSR version of communism, distribute their versions of news and education, promote Soviet culture, and provide music and entertainment. Without an extensive AC mains network to power radio receivers, what are the options? Dry battery power. The downsides: recurring cost of replacement of batteries. Low and high temperature conditions limit performance. A proven record of a managed economy unable to maintain reliable supply chains for consumer products. Local generators powered by fossil fuels. The downsides: expensive to make and requiring constant maintenance within a system with chronic inabilities to maintain reliable distribution of parts and refined fuels. Wind power charging batteries. The downsides: winds unreliable throughout the year. Many areas with harsh weather disabling generators. Battery charging maintenance schemes not as sophisticated as now. What are alternative methods for producing small quantities of constant electrical power? Scarcely any that would service the majority of their needs. One method, first discovered in 1821 by Seebeck and correctly explained by Ørsted, who named it a thermocouple a year later, was a junction of dissimilar metals that, when placed on a source of heat, will produce a voltage difference at the cool ends of the metals. This voltage difference is very small, on the order of a few microvolts per degree C. These thermocouples can be connected in series to produce higher voltages in an assemblage named a thermopile. The size of the junctions can be scaled to deliver a greater current, but energy conversion efficiency remains well below 1%. There was little practical use made of the Seebeck effect in the 19th century, the most work having been done in attempts to make thermopiles to provide low voltages for electroplating over hours at a time, when practical small dynamos had yet to be developed. From 1890, thermocouples had been characterized sufficiently to serve reliably to drive galvanometers and later D'Arsonval-type meter movements for measuring industrial and chemical process temperatures. The first attempts to generate enough power to operate a radio receiver come in the late 1920s in Great Britain. These generators used elimination gas to fuel the burner. Using only thermocouples fabricated from various metals and metal alloys required an inordinate number of junctions to provide voltages high enough to operate vacuum tube receivers. Indications are that these generators were produced in very limited quantities, with only a few surviving in museums. I know of no other attempts in the 1930s to market such a generator to power broadcast receivers. In the middle 1930s, the Ukrainian-born academician and physicist Abram F. Ioffa is credited with pioneering investigations into the properties of semiconductor materials such as zinc antimony that, when bonded to copper-nickel alloys, could produce thermocouple junction potentials of about 55 millivolts in production generators with conversion efficiencies below 4%. The first claimed use of this technology in Soviet industry was during the Great Patriotic War. A small 1 or 2 tube earphone-only radio, probably of the space charge variety, was supplied to partisans. The generator consisted of a metal pot with an array of semiconductor junctions bonded to the bottom of the pot, the pot being suspended over a fire. The pot was filled with water and became the cold side of the thermopile junctions. Before World War II, broadcast radio production in the USSR had been very limited. Following the war, decisions were made to develop various reference designs for broadcast radios that could be manufactured in quantity. In 1949, Alexandrov Radio Factory engineers were tasked with development of the ARZ-49 battery-operated, very low-power receiver with loudspeaker. Designed around the USSR's first miniature vacuum tubes, in Russian slang called finger lamps, they had reverse-engineered RCA 7-pin miniature tubes. The tubes had been provided to the Soviets during World War II through a Lend-Lease program. These tubes were contained in samples of the Galvin Manufacturing Company, Motorola, designed BC-611B handy-talkie used for short-range military communications. As mentioned before, reliable distribution of dry batteries, or reliable wind charger systems, was certainly recognized as a substantial problem. Professor Aofi had earned great influence in informing government planning and was convinced that a thermoelectric generator could be developed to power small radios requiring only 2 to 4 watts power. Cost of operation would be very low because it could use only the waste heat of an oil lamp. By 1953, the first iteration of these generators, the TGK-3, was available for production. These first versions of the generator had 2 banks of thermocouples. One supplied 1.2 volts at 300 milliamperes to light the tube filaments. The other bank of thermocouples supplied about 10 to 12 volts to power a mechanical vibrator-type DC to DC converter, delivering about 90 volts at 10 milliamperes. The delicate DC to DC converter was something of a reliability issue and certainly added considerably to the initial system cost, but it worked well enough and some thousands were manufactured. There was another incentive to develop these generators. The communist model, with thousands of farming, mining, and forestry collectives, covered large areas without wired communications. They developed low-power two-way radio telephones. A claim of some 70,000 Harvest Series two-way radios were made over 10 years, some percentage of them being powered by this thermoelectric generator. A slightly larger version generator, 10 watts, and converter with added storage battery to source the peak load of the transmitter in talk mode. Articles in Radio Magazine discuss theory of design but give no descriptions of manufacture. That was a state secret. In 1956, they had perfected a method of making high-density series slabs of thermoelectric junctions that could be assembled into bars producing about 10 volts. 10 of these bars would provide 90 volts directly, thus eliminating the considerable expense of the DC to DC converter. My example is never going to power a radio again. The design life of these generators was said to be 5,000 to 7,000 hours, which was considered to be 5 or more years of normal use. This example is heavily corroded by many hours' use. Poor assembly of my 1958 model TZGK 2.2 allowed combustion gases to get to slab connections. But I had to give it a try. Maximum output when heated with a 1,000-degree heat gun was about 10 volts at 2 milliamperes, just enough to light one small white LED. But my generator is entirely suitable to be cleaned, painted, and placed on exhibition. You certainly would not be burning this lamp on exhibition. When given to me by a collector friend, It was complete but badly corroded and not at all presentable. This lamp is fitted with a tubular argon-type kerosene burner. The steel and brass stamped parts are swaged together and in different states of deterioration. I judged it impossible to properly replate the assembly. The font had 2 small pinhole leaks. I repaired them for cosmetic reasons. Some of the later fonts were painted with aluminum, but there was just enough remaining forest green enamel remaining on this font to identify my unit should be painted forest green. I had to locate proper-looking stamped brass chain that I finally learned is called Windows sash chain. A local custom sheet metal shop helped me to recreate a proper flue pipe to replace the heavy piece of aluminum scrap pipe. A thick asbestos bushing between the top of the clear glass globe and the bottom of the generator was replaced with safer ceramic fiber blanket material. All other asbestos at the base of the radiator fins was saturated with clear acrylic resin. The original plastic insulated wire looked terrible, but cleaned surprisingly well. The little round box houses 3 receptacles that mate to the radio's existing battery cable plugs. I note that in recent decades, a very few new old stock generators have been found in South America, Southern Africa, and former Eastern Bloc European countries. When they do show up, prior to 2008, they were trading in the range of $800 to $1,200, certainly out of my price range. Now that I had an authentic generator designed to substitute for standard dry batteries, I wanted to find an appropriate 1950s USSR-made battery-powered broadcast receiver. From 1950 until 1963, there were a total of 12 Soviet-made radios that could be powered by these generators in place of dry battery blocks. Thanks to collector Barry Etheridge in Georgia, USA, I acquired an Iskra 53, this one built in 1958. This is essentially the Iskra 49 limited production radio with a new molded phenolic, aka Bakelite, cabinet. With the back cover removed, you see a chassis of a little 4-tube superhet receiver, an IF transformer that looks a little bit odd. I prepared to remove the chassis for inspection. I unsoldered 2 wires going to the loudspeaker voice coil, removed the chassis, and prepared to unsolder the soiled battery cable for a proper cleaning. But I touched the soldering iron tip to one of the cable connections and nothing happens. No melting of the solder at all. A closer inspection, and I realized that 100% of the chassis component and wire connections are welded. The little inset picture shows how the wire leads were prepared before applying the welding electrodes. I found a few Russian collectors online, all under 40 years old, that tell me that there were at least 2 broadcast radio receivers and 2 television receivers that use welded connections. They understood this to be a way of connecting circuits in cheap, i.e. third-class products. But some detective work indicates otherwise. In the early 1930s, the government of Germany fell under the control of the Nazi Party led by Adolf Hitler. A high priority was placed on rebuilding the German military. This required some raw materials not found in the German homeland in commercial quantities. One of these was tin. Germany got most of their tin from South America. It was evident that at war, those shipping routes could be blockaded. 2 companies in Germany began to study how to weld small electrical wiring and components. By 1942, some percentage of German military electronics were being welded in order to conserve a scarce commodity. The techniques found use and even preference to conventional solder, especially in production of avionics, aircraft engine control and monitoring, and very importantly, operation of rocket bombs like the V-1 and V-2. The Western Allied powers, of course, wanted to learn as much as possible about technology of the German war machine and already had functional military agencies such as the Enemy Equipment Intelligence Service analyzing their methods by 1942. There were interrogation and recruitment programs for captured personnel under Operation Overcast, later named Operation Paperclip. The Soviet Union was operating their own similar agencies as the Eastern Front fell to the Red Army, and they managed to secretly organize a stunning event, Operation Osavakium. In the early hours of October 22, 1946, they loaded some 2,500 engineers and specialist workers of the former Nazi war machine, headed to various Soviet territory installations and factories, along with some 4,000 family members. It would be 10 years before some of these people had the opportunity to return to East Germany. This included a massive operation to transport from Red Army-held German territory as much related manufacturing equipment as possible. Much of German military technology was superior to that of the Soviets, so they simply began building, in many ways, copies of German equipment. Soviet workers had to receive new training and acquire new skill levels to execute these German designs. They had never used these considerably more difficult wire welding techniques for electronics going into aircraft, rockets, jet engines, etc. What better way to hone their craft and then identify the best workers for the task than with months of practical work wiring cheap broadcast radios and televisions before assigning them to work on high-value military equipment. Making repairs around defectively welded circuitry was far more difficult and time-consuming than conventional tin-lead soldered junctions. They needed people that could get things right the first time, every time. Let's take a tour of this power-thrifty little broadcast receiver with welded circuitry. The Iskra 53. The Russian word Iskra means spark. A perfect name for a welded radio, don't you think? First off, like many European designs, it was deemed necessary to tune both the long-wave and medium-wave broadcast bands. The Soviet-made finger lamps were often direct copies of the RCA 7-pin miniature tubes. In later years, these tubes would even have the equivalent USA markings like 1R5, 1T4, etc., in addition to the Russian nomenclature. But however, not all their miniature tubes were electrically equivalent. The superheterodyne intermediate frequency was 175 kHz and was tuned using threaded ferrite slugs. In order to obtain the most power-thrifty operation down to the minimum specified B battery output of 60 volts, required that they use a clever circuit consisting of a third winding on the audio output transformer and copper oxide rectifier to provide a tracking grid bias dependent on the volume levels of the audio content. The two dry B battery blocks each have an 8-pin receptacle. Note that the receptacle has two keys in the center of the receptacle. When new, the battery cable plugs are inserted so as to deliver 45 volts. When the battery discharges down to 30 volts, The plug is rotated to the other receptacle position, connecting an additional 15 volts to the string. Note, there are two chassis-mounted pin receptacles in parallel with the plate circuit of the audio output tube. I'll explain shortly. A side note is that this tube does not have an electrical equivalency to any RCA tube design. Resistors are exact copies of Siemens products circa 1940. Capacitors, both electrolytic and paper dielectric, are also essentially German copies. Note the two gimmick small-value capacitors. Excess insulated wire is wrapped around a copper wire post to bring a circuit to peak resonance simply by pulling off some of the wire and clipping. Note how the various RF and IF coil bobbins are glued directly to a phenolic board. There is absolutely no opportunity to repair these parts. Certainly another reason for the workers to be trained to get the job done the first time, every time. I mentioned the two connections to the primary of the audio output transformer. You might have expected those pins to be marked as connections to a remote loudspeaker, but no. This is where you could use your radio loudspeaker to connect to the local wired radio distribution you may have had in your apartment or workspace. I am not aware of any other nation to have a significant program to apply thermoelectric generators to operate vacuum tube broadcast radios. Professor Aofa served later as a top atomic scientist and administrator. This led to projects to develop thermoelectric generators using radioisotopes as heat sources, used for such things as powering automatic lighthouses, meteorological stations, and radio relays. After the dissolution of the Eastern Bloc in 1991, many of these nuclear thermopiles were simply abandoned at the end of their service life. There was great international concern about the possibility of the leftover nuclear material being used in so-called dirty bombs. There were international agreements signed to methodically decommission these units, but soon the program fell apart. As far as I know, there is no credible accounting of whatever remains.
Well, that was awesome. I must say I learned something that was totally unknown to me about radio history and technology and the war and all that. Fascinating stuff. And let's open it up for questions.
I have a quick comment. This is Keith.
Go ahead.
Several years ago, before we were all locked in our houses, I was at a flea market in Wisconsin, and I came across what I now know is a thermoelectric generator. But at the time, I had no clue to what it was. It was in rough shape, but the pictures you showed were exactly what I was looking at. The guy,
there were only two models or three models made in any quantity.
the guy that was there at the flea market had it labeled for $30. Shame
on you.
Me not knowing what it was, I passed it up, but it did intrigue me a little bit. But now that I know what I know, I couldn't get the $30 out of my pocket fast enough. So that's my little comment on it.
Yeah, there were some attempts, and I think probably most of you know that there were some attempts to make little thermoelectric generators to power transistor radios. And The idea being that there were places like in Africa, Central Africa, and all that had the same supply problems with batteries and so forth, but they never could get the cost of the thermoelectric generators down to what somebody in darkest Africa could afford. So they went nowhere.
Mm-hmm.
But these were made in maybe 50,000 or more of the ones that were used strictly for the radio broadcast receivers. And of course, as I mentioned, there were allegedly 70,000 of them used to run the two-way radios.
Right. And, you know, if these items that we find all the time, if they could talk, it would be great to find the information on it. But like I said, at the time, I had no idea what this thing was. I just saw a couple wires hanging out of it, and it intrigued me, but that's as far as it went. You know, it wasn't, like I said, it was in rough shape, and I really didn't want to spend $30 on something I had no idea what it was. I figured I could spend my $30 on a nice lunch somewhere.
So Robert, I have a question. Did you ever have to go in and attack those welded connections and reattach any wires or anything?
Well, there were no, are you talking about in the generator or?
In the radio?
Oh, well, no. And basically, I don't care if the radio works. What I really care about is if it's complete. And the radios could certainly be made to work if you wanted to. I presume that the paper dielectric capacitors in there are too leaky, especially in a very thrifty design like that, where currents are so low that you would have to replace those. And then I don't want to destroy the historical
I understand,
accuracy.
yeah.
Now, if somebody had already been in there and hacked it up to make it work, well, then I would have had fun and put other parts in there to make it work, because I wouldn't be destroying a good historical reference. So,
Robert, I have a question and a comment.
sure.
The National Capital Radio Television Museum in Bowie, Maryland, has a kerosene lamp with a solid state radio built in it and a thermocouple. And they said at the time that it was a good practical design. Batteries are now so universally available that it didn't get much acceptance.
Yeah, those seemed like a good idea, but again, even though those were made in China, they were still the initial purchase price was still too high for their intended market. The only market that developed were the rich Westerners that saw a gimmick and said, "Hey, that's cool. I'll buy one of those for the $50 or $60 that they were trying to get for them." But for their intended purpose, they never went anywhere.
I was also fascinated by the detail you went to and wondered if you could say what kind of research sources you had to go through and over what length of time to develop the presentation.
Well, I wrote a paper for the AWA Review, volume 30, which is online. And if you've never looked at the AWA Review, which you can download in PDF form, everything but the latest 3 volumes, I think. And that is a fabulous source of peer-reviewed papers. And so one of the things that I had as a problem with this project is that I don't have any functional knowledge of Slavic languages and the Cyrillic alphabet. So, but fortunately, that Soviet magazine called Radio, there are scanned issues of all those from 1947 on into at least the 60s. And but they're in this deja vu format. They're not in PDF format. And so getting through those issues, I would just find pictures or schematics. And then once I found a picture or a schematic, I could zero in on a little bit of a text and do a OCR on that text, and then go into Google Translate. So and figure it out that way. And it took me a couple hundred hours to develop research for the paper, but it was fascinating, and it was hard work, but I don't regret having done it.
Yeah, that's certainly it shows in the presentation how much effort you put into it, Robert. It's a great thing that you could share that with us. And if I could ask you to put the AWA link in the chat so people could find that stuff, that would be great. Not just a generic link would be fine. And
Okay, I'll turn away at that right now.
Yeah, so if no other questions for Robert, we need to move along to our next presenter, Norm Smith, who did a presentation for us a year ago, last January, on the Zenith Royal 500. And if you missed that, you can find it on YouTube. But Norm is an author. He's written books on transistor radios, and this is the one about Zenith, which is an excellent book. I recommend it. And today, Norm is going to talk about all the clones that the Royal 500 from Zenith spawned. So, Norm, send in the clones.
All right. Yeah. I titled this From Z to A because that's actually the opposite from A to Z, but from Zenith to Admiral. And the reason for that is that it seems like whenever Zenith came out with a really successful design, within the next year or less, Admiral would come out with a very similar radio in design, just enough to not get in trouble with copyright or patent infringement, but they could market it under that same guise. The radios, I have one I'm going to show here before we get to the slides. This is Zenith ZNet. It was made in 1949. It's a tube portable. Used those 1R5, 1U5, and so on type tubes. And Zenith was very successful with this little portable radio. The antenna was in the lid. And so that's why it was kind of clunky to carry around, but it was a great little radio. And within a very, very short period of time, Admiral made this one. Note the similarity of design. And again, used about the same type of electronics. Made it just enough different that there wasn't any problem with the legal department. And so it's been my observation with doing all the transistor radios that I've done over the years that there were a lot of cases where Zenith kind of led the way with the design of a radio, and other manufacturers simulated it pretty closely. And so I call them clones just because at least in the marketing side of things, they were certainly after what Zenith had done when Zenith had success. And so we can go to the first slide that we have here. These two radios are the Zenith Royal 1000, which was their first transistorized transoceanic radio. And to the right of that, you'll see the Admiral 909 All World. And that came out very shortly after the Royal 1000. It was actually a pretty great radio as well. I'll have to say that for Admiral. Their electronics quality was very good. Another great Chicago company. But they made the 909, which was the similar radio to the Royal 1000 as far as frequency coverage and such, and a great radio. When Zenith then came out, and we'll see it on the next slide, with the Royal 3000, which now included FM. That's when FM was just starting to catch on. Admiral redesigned theirs to be the model 1009 all world. Again, very similar radio, but with the addition of FM. And quite honestly, I think Admiral might have done a little better job with the FM part of the radio than Zenith did. Those are both, the Admirals are very rare radios. Not too many are around anymore. I don't know how many they actually sold in the beginning, certainly nothing like the quantity that Zenith was able to produce. But a nice radio nonetheless. And while we're talking about the transoceanic type radios, I'm going to bring this one up. And if we can go to, I may have to back up a little bit. This is a JVC Nivico, Japanese, and it's their transoceanic type, and very similar in construction as far as the, as far as appearance goes. Totally different on the inside, certainly not a transoceanic. But the point of it is that when there was a successful design, a lot of people simulated to get their piece of the market. What's interesting about the transoceanic transistor type radios, actually Magnavox was the first. They came out with their AW100, which was a really great radio, outperformed the transoceanic. It wasn't particularly attractive as far as its styling went, but a great radio. Magnavox made two transistor radios that they actually made for themselves. They made that AW100 Intercontinental, and they also made actually two pocket transistor radios, the AM2 and the AM5 in Fort Wayne. They were one of the first companies to go offshore to get their transistor radio product. They went to NEC. So they were in and out of it really quickly. And it's too bad because the stuff that they made was very well engineered. This is the Heathkit GR43, which you could actually buy in kit form. Notice the similarity to the Royal 3000 design as far as the outside of the cabinet went. It was a very different radio on the inside and kind of a mediocre performer compared with the Zenith. But it was neat that you could buy this kit radio, and a pretty sophisticated kit radio. Again, not a lot of these have survived, but it's a nice one to have in your collection. This is the Sony Earth Orbiter, model CRF 5090. I think they also made a CRF 5100. Notice the similarity to the radio on the left, which is the Zenith Royal 7000 transoceanic. So there were a lot of people looking for that piece of the market. It's kind of interesting to see how some of them did a pretty nice job. The Sony works pretty well when it works, but it is an absolute nightmare to work on. They definitely did not have the serviceability that a Zenith had. Real Tone, JVC, Juliet, Philips. In fact, one of the, I think it's Goldfinger, James Bond movie. There's a really nice Philips transoceanic type radio. And Lloyd's, which is another company, it was an importing company that bought some pretty nice radios from various manufacturers, and they had a fairly decent transoceanic type radio. On the next slide, we're going to move to the Zenith Royal 50. That was Zenith's little shirt pocket transistor radio that was very successful. And because, again, it was successful, there were other radios that came along that certainly tried to emulate it as far as looks went. You'll see on the left, you'll see the Zenith to the right in that photo, the red and white one, and the green one is the clone. And notice how they certainly copied the style. And if you look at the right-hand picture here, you'll see the Zenith with the red front in the center. And you're going to see on the left, Jewel. And that one copies an RCA. So it was a hybrid between an RCA and a Zenith design. That was model TS10. And it was marketed under a bunch of different names. There were Jewel, Grinnell's, Hudson, Ambassador, Majestic. They were made for the house name for some of the large department store, Hudson's in Detroit. So they made those to be marketed through a lot of the large department stores. And on the next slide, we'll see some more. You'll get a better idea of the RCAs in the middle, the gray one. Look at the red one on the left, and yeah, they kind of simulated it. And of course, there's the Zenith on the right. So it's a hybrid of the designs. And that company sold a lot of radios. Fortunately for them, by the time they did this, Zenith had moved on to newer models and didn't really take them to task over having infringed on a lot of design. We'll look at the next slide and we'll get to the Royal 500, which obviously we talked about the evolution of that radio over the years in our last presentation. But I wanted to get a little more in depth with the clones that were done there. This one here is a Webster, which was made in England. As you can see by the photos, pretty close copy. The front view, the side view. The electronics was very much different. There are, actually, I think that's the only one known to exist. I got that from the Zenith legal department when I did my book. And when that one appeared, Zenith attorneys told them cease and desist. These will not be manufactured and or sold, certainly over here. And I've never seen another one. We'll move to the next slide and you'll get to see the back and you'll get to see the inside of each. You can see the design was very, very similar, but the electronics was much different. It had a very primitive circuit board, wasn't very well made, 6 transistor. It was, like I say, never marketed, but it's just interesting that they came that close, certainly with the outside design, to try to market something to compete with the Zenith. Next, we'll move on to the next slide. We'll see some more radios. Bulova, a very interesting radio. You can see on the outside, looked quite a bit different than the Zenith, but let's look at the slide on the right. You can see that the exact location of the IF transformers, the oscillator, all the parts are in the exact same location. So that was a real blatant copy. Fortunately for them, by the time that was done, Zenith had moved on to a newer design. And so that radio actually got into production and was sold mainly through jewelry stores. And not a bad radio. It's very similar to the 7 transistor earlier Royal 500s. On the left, you're going to see a Gimbals radio, Gimbals department store. Again, look at the similarity to the Zenith design. Where the Zenith was made of high quality materials, that was made out of really inexpensive plastic. But there again, look at the chassis side by side. They're nearly identical. You're going to get to see the dial script. They copied it. Look at it closely. You'll see they absolutely copied the Zenith design. These radios were not a bad radio at that time. A Royal 500 was $75, by the way. And that was in 1958. At the same time, you could buy the Gimbals radio for, I don't know, $40 or $45. So they were looking to take a piece of the market. And just interesting how close that they came in copying Zenith's designs. These are more of the radios made by that same group, different names, Jewel, Artone, Ambassador. Again, sold through major department stores primarily. Jewel isn't Jewel Grocery like up in Chicago, but nonetheless, this model also was a TS10. I don't know why they kept using the same model number. And what was interesting about these is they came, I've seen them in 8, 10 transistor, and really the radios were the same. The only difference is they put a couple extra transistors in the output circuit, and they weren't really even in the circuit. They were just parallel. But so it was really still a 7 transistor radio, and they used a transistor as a detector. They just used one side of it. So that's how they came up with the 10 transistor design. Again, they were made in the USA. This is a later model of the TS10. Major change in this radio, still the same concept. The chassis was entirely different. They went to a 9-volt battery, which was, as memory serves me, I believe it was a 206. which was a C-size battery with a snap on each end, 9 volt, and entirely different circuitry, in no way similar to a Royal 500. But marketing wise, still, you can see that's what they were after. Again, they sold these under many different names. This one's kind of hard to find in good condition. The metal work on it and the artificial chrome on it wore off pretty quickly. And again, pretty inferior plastic. So if you find one of these that's in really nice shape, it's kind of nice to add to your collection. Other major US competitors also joined in. You can see the RCA. They kind of, in concept, we're looking for that style of radio. Motorola did the same thing. In fact, I have a couple of radios here that I want to show on camera. The Japanese also got into it. You can see in concept kind of where they were going with these. And get my hand out of the way here where we can see it. And I'll bring here another one. This is that one there is a Eden. This one's a Empire. Again, you can see where the concept was being simulated, although the radio, quite honestly, is quite a bit different. And actually a pretty primitive design. And our friends at Sharp, Thermo-electric, you can see the similarity between looking at the Royal 500H, although this doesn't really have an oval speaker, it has a round speaker, but it looks like it, big speaker. And the slide rule design like the 500L. So there was an awful lot that went on with people trying to market on the success of Zenith. And that's kind of what I'm trying to show everyone here. Here's the Royal 500L on the left. And as you can see on the right, a couple of Admirals, one even with FM. And again, trying to work on that same styling that Zenith had. And as far as I'm concerned, the Royal 500L was a real step down for Zenith. They couldn't afford to make the really good ones anymore. They had to cut costs. That was their design. And the N that came after that was even less desirable. But nonetheless, other manufacturers tried to follow their lead. And so that Admiral, the one on the right, is particularly a nice little radio. Hard to find in good condition. They got corroded real easy. So if you find one of those, it'd be a nice one to add to your collection if you're a Zenith collector. Now we're going to look at some earlier Admirals that copied Zenith in some way. Look at the battery compartment and how it's really laid out. The Admiral became a horizontal rather than a vertical set, but nonetheless, the way the chassis was laid out was very similar. The battery compartment, if you look at it, even the way the speaker was attached to it was identical. And we're going to see a couple more here in the next slide. On the top, you'll see the Admiral. And on the right, that yellow and white one is a Glory Tone, a Japanese copy of the Admiral. So this stuff really went around with people trying to simulate other designs. That Glory Tone could be found with several different names. It was a Japanese knockoff of the Admiral, which was a knockoff of the Royal 500. This is another Japanese knockoff, the XL. Note the similarity to the Admiral 800 or TR 801, I believe that is. Anyway, marketing was pretty good. They sold a lot of radios. So it gives you a little bit of an idea of just how things were going with the copying. Here's one that was really interesting. These are a pretty rare radio to find because they came out the same very shortly after Zenith released the 500H. As a result, Zenith said, no, you're not going to bring these in or we're going to court. A few managed to trickle into the country. I've seen a few of them, but a really rare radio, the Lloyd's TR 800. I've also seen this radio one time marketed under the name of Muscat, M-U-S-K-A-T. But note the similarity there. They turned the radio on its side, made a horizontal set rather than vertical, but you can tell who they were after. If you look at the side shot, and we'll move on to the next slide, you'll get to see, look at the dial script similarity. the Zenith on top and the Lloyd's right below it, and even the escutcheon in front of the dial. Of course, the Zenith was nice quality metal, and the Lloyd's was plastic. Look at the back design, the way they vented it. And let's talk about that venting, because that made a huge difference in the fidelity of that radio. Zenith spent a lot of money to make that 500H a great sounding radio. The extended range speaker, the cabinet was acoustically designed so that it didn't have a lot of resonance, and was vented in the back so the speaker could actually breathe very nicely. Well, you can see what Lloyd's did. They vented theirs in the back too. And although they had that huge speaker grill on the Lloyd's, what they didn't have was the huge speaker. There was actually a round speaker located behind that large oval, what appeared to be the speaker. Well, there you go, you can see it. And that's the Lloyd's presentation kit. When you bought the radio, you got the batteries, the earphone, the radio, and for the remarkably nice price of $59.50. A real Royal 500 was $59.95. So, hey, what a bargain. And then when you went to the store, you could also find out that that radio actually you get for about $30. But what's interesting about that round speaker in that Lloyd's TR-800 is it sounded pretty good. If you didn't know it wasn't an extended range speaker in there, you might have thought it was. They actually did a pretty good job of making that TR-800. It was a pretty good Japanese radio. We've now moved on to the Royal 790 Super Navigator, which was Zenith's navigation radio, and a great little radio, AM, long wave. And this one happened to have also the Marine band, the old 1.6 to 4.5. A very successful radio for Zenith that came out as the 760 originally and became a 780, then a 790. This one happens to be the 790. Another successful type radio. They used it for navigation as well as just being a great radio. And it was also copied. And we'll see a couple examples here. Admiral again, from Z to A, their Clipper, a great radio, worked absolutely as well as the Zenith, a very unique dial design. Actually, I think a very preferable dial design. It had the navigation capability. On the left, you can see the Weathermaster ST8J, which was a Japanese, again, copy of that type of design. In fact, if you look at a Royal 760, if you have one or look in the book, you'll find that the knob configuration and everything is the same as that Weathermaster. So there again, Z to A, marketing wise, a lot of people sold a lot of radios riding on the heels of Zenith's success.
Well, thank you, Norm. That was excellent.
Well, I hope everybody enjoyed it. For those of you that collect transistor radios, there's still a few out there, and there are some rare ones out there, so keep looking.
Very good. Anybody have questions for Norm?
I have a question for you, Norm.
Yes.
When you say the navigator and it was used for navigation, what do you mean? Directionality or different?
Yes,
bands?
it was. Yes, it was. Primarily, they tried to sell it to boat people. And, at that time, we didn't have LORAN, we didn't have GPS, we didn't have all that stuff. And so, like where I lived on Lake Michigan, if you were out beyond the shoreline where you couldn't see anything as far as the shoreline landmark, you could navigate, which you could really do with other radios as well. They were a very directional antenna. And so you could triangulate and at least find out kind of where you were out on the lake and or the ocean if you were at distance of those stations. The long wave beacon stations you could pick up, which of course told you which harbor they were coming from. But even the medium wave broadcast band, you could triangulate for Chicago, Green Bay, Muskegon, and get a pretty good idea of where you were out on the lake if you had no idea. They also tried to market to people in airplanes. Trust me, that didn't work.
Thank you.
But actually, as a boat navigational device for the time, it was useful.
Well, Norm, your presentation, just like the last one, was just a wealth of knowledge, and it's just incredible how much you know about Zenith and transistor radios in general. We look forward to your next presentation.
I'm going to try to find something, I'm not sure what yet, but different, maybe not Zenith.
Okay.
I have a quick comment for Norm.
Sure.
On the oval speaker, and I believe it was the Zenith, the ones that were not centered in that oval was off-center. Which one was that?
That was in the Royal 500H, the Royal 500H-1, which was made in 1964. It was also in the Royal 400, which was marketed at the same time as the H, and is still a great sounding radio. And those are the only radios that had the off-center voice coil, extended range 3x5 speaker.
Okay, that was my question. Thank you.
Sure.
I got it out now, real quick. A Kraft macaroni and cheese transistor.
Oh, yeah. Yeah, great.
Now, who
Yeah.
made that radio? Who made that one? Do you know?
Oh, I love it.
I'm sure it had to
cheesy
be.
company.
I'm sure it had to be either Hong Kong or China.
Probably. I'll see if I can figure it out.
Okay. Any other questions for Norm? Well, great. Thank you very much again, Norm. And we appreciate you taking the time to work to make these presentations with us. So,
I'm very much looking forward to Radio Fest.
all right. That's great. We'll see you in person in August.
Sounds great.
Okay. Our third and final presentation is by Tom Kleinschmidt, our president of ARCI, and he's going to do part two, continuing from last month's presentation on how to identify radios and who made them. Tom?
Thanks, Tom. This gets a little more specific to, obviously, to Sears as a company, and EIA, which is a trade organization. And there's a lot of detail in here, and you'll either appreciate it or not. There is a companion article that will be in the ARCI News coming out in February. So bear with me, and if you want to ask questions along the way, feel free. Let's get rolling. So first, we want to start out with the trade organization. Now, RMA, which we'll see in a minute, became EIA, but they kept changing their name as they industry changed. So if you look at it, they started in 1924. Associated Radio Manufacturers, as far as I know, there's no logo associated with that. Then they became the radio manufacturers, the radio television manufacturers, radio electronics. You can see they were just permutating as the technology changed. Finally, they just generically went to Electronic Industries Association, and that was the longest name. That lasted 40 years. Then they changed it to an alliance, so you can see that the shift in the market again. And we'll talk a little bit more on how they are as an organization. But right now, there's an organization called ECIA that owns the archives of the EIA codes that we're going to talk about. And they stopped assigning EIA codes in 2001. So here's the litany of logos. And keep in mind, those ones in black and white are also in color. If you look at the beginning of the presentation, they could be very colorful, but usually on printed matter, they're in black and white. And they kept the same format for multiple years until they went to the Alliance name for the group. So the round logos are the ones we care about, by the way. Those are the ones that appear on radio chassis or the tube layout or some other part of the radio. You'll also, if you look at SAM's schematics, that's where all those top ones came from, in fact. Those are on the schematic folder because SAM's was a member of what was ultimately the EIA for our purposes. So they launched the product code notion in 1946, as far as I can tell. It's a nice article, which actually is fully reprinted in the coming up ARCI News by our old buddy Alfred Girardi. And keep in mind, he was the guy that has the secret decoder list in the book we talked about last month. SAMs also published them earlier on. So if you have any of these sets, 570 and 92, there are lists of the EIA codes in there, and they changed regularly and it got updated. And in the early days, they would take out companies that were no longer manufacturing. The good news is the archive has everything in it. So the magic is this link right here. And they also have the SAMs stuff we just talked about. I know I'm going through a lot of nauseum here, but it gets better. So here's some EIA codes. And what I did is I plucked out some common ones on the right. And back to Norm's thing, we have Admiral at the top and we have Zenith at the bottom. So sorry, I went A to Z instead of Z to A on that one. But obviously companies we've all heard of and deal with all the time. A lot of component companies, they went to 4-digit numbers down the road as they got more and more companies. This is just the beginning of the list that I just took a little chunk of here. There's no way I could print the whole list out, but it's easy to download. They actually have it on a spreadsheet, so you can download it. So from that article we saw from Girardi previously, they had a proposed numbering scheme, meaning that if you had this 6-digit number on a product, the 101 is who made it. Again, Admiral in this case. And 615 is 1946 and the 15th week, which is April 7th to April 13th. And so then you can see the same thing where 274 is RCA, 608, again, 1946, but in this case, the 8th week. We'll see a little bit of that in action in a minute. Again, suggested format, a lot of people didn't follow. So here is a Silvertone tube layout that has the RMA logo on it. So that's where it looks like in black and white. And that color one that was at the beginning of the presentation actually came off the chassis of the same radio. So you don't always have to have a radio logo, I should say, an EIA logo. These are both Tom Zaczek radios. So when he was proofing this presentation, he goes, hey, I figured out who made these radios. So it says 161 here. It's quite faded on this one here. It says 161 as well. But Coronado, as many of you know, is a Gamble's store in Minnesota brand name. And Eckstein, who I never heard of, actually made this radio for Coronado. We all know that Wells Gardner, all kinds of people made radios for Gamble's stores for under the Coronado brand name. And then Eckstein also marketed radios under their own name. And so that's the one on the right here with the picture of the back of it. The thing I'll caution you on is that logo didn't always get updated because if our product kept running, they never changed the logo. Or and I think I mentioned it further on, but in that those 3 logos that you saw from the SAMs previously were all in one PhotoFact folder. It's just that they never changed it. So let's look at some components because that's another place where EIA codes really pay off. And so these first 2 are both 5U4s. They're both a manufacturer code 188, which happens to be General Electric. And you notice they didn't follow the format that was suggested in the Girardi article that came from the EIA, which wasn't the EIA then, but it was whatever their incarnation was. But again, 1949, 17th week. And in the case of GE, they added a dash number at the end, which is the plant number. Same here, but this is an airline branded tube that was made by GE for obviously for wards. And this one was a plant that we'll talk about in a minute. And then Wagner Electric, who owns the Tuxall brand, they did follow the format. So you can see that 322 is Wagner. And again, the 926 is 1949, week 26. So as you all know, when you go researching things, you go down some rabbit holes. And if I was going to do this nice and crisp, I wouldn't drag you down the rabbit hole with me, but there's some fun stuff I found. So this GE5 plant is in Owensboro, Kentucky. And, oh yeah, I forgot to mention that the single digit dates from GE had a short lifespan, 49 to 55. Be a whole nother presentation to talk about the fact that they went to to letter codes later on. And I won't go down there right now. But here's the GE plant. And I just thought the fact that they had this tower out front, probably a water tower, they added this little exhaust tip piece on the top and they made it look like a GE miniature tube. And this used to be the Kenrad factory. GE was a partial owner of Kenrad, and ultimately they bought it in 1945. So the building's still there, the water tower's still there, but it doesn't have the tube motif on it. And of course, obviously, GE doesn't make tubes anymore. Tungsol, another one of these little fun fact things, came from a conglomeration of the word tungsten and sol, meaning sun. So it's actually tungsten sun. So a little bit more to talk about the EIA RMA continuum. They did a whole bunch of stuff. They created standards. They were probably one of the major electronic standards body for the US. And so the ECA, which I believe became the ECIA, is who owns the EIA numbering scheme. But if you're familiar with early solid state technology made in the US with a JEDEC number system on it, where a 1 end would be a diode and a 2 end would be a transistor. And then they had a government branch, Telecommunications Industry Association, which I did a lot of work with, not directly, but was affected by when I worked cellular telephone at Motorola. TIA was the standards body. And then you might have heard the Consumer Electronics Show, the CEA puts that on. But all of these groups were under the EIA originally, and the EIA split off into all these little splinter organizations. They also did training stuff, looks like particularly for schools. You can see that John F. Ryder printed this version, but it's designed by RETMA, so it'd be Radio Electronics Television Manufacturers Association. There's a basic radio servicing course. This is actually a workbook, and it has the EIA logo on it. And so this is 1961. This one, I don't know what the year is. I didn't have that handy when I looked it up. But the one we live with and die with every day is the resistor color code. That's an RMA, and then later on it would say EIA or whatever incarnation of the organization there was on the standards. And there's two places you can find that stuff real easily. One is the Girardi book we talked about last month, and if you have one of those Allied electronics books, which you can probably see in the thumbnail of me, there's a billion different versions of, but all the EIA color codes are in both of those publications. So we'll shift gears to Sears. And so same label from the same radio, you'll notice it has this 101 number at the bottom. And in Sears parlance, 101 is colonial manufacturing. And the 59 blah, blah, blah number is how you get parts. Anybody that used to go to Sears to buy parts, you knew you had to have that number. And the radio happened to be called a model 4588A, but this is the number you would use to go buy parts. And the number we're familiar with mostly had a decimal point in it. You know, that's what they evolved to later on. So here is most of the list of Sears numbers. And I just highlighted some of the big companies that you'd be aware of. So, you know, Stuart Warner turned out to be at 100. Zenith was 121. They didn't buy from everybody, but they bought from a lot of people. And some of this stuff is musical instruments, because that's how the Silvertone brand name came to be. And some of it's wind generators and accessory parts as well. This set of numbers I found in two places. Stein's book on Silvertone catalogs, he's got this list in the back. And then there is a Antique Radio forum page that had the same list with some variations. So this list is fairly solid. But this list, which came off just the Antique Radio forum page, you can see there's all kinds of question marks all over the place. Also, you'll see that this 757 code is for multiple companies, and we'll talk about why that may be in a minute here. So this this page I would definitely do a little bit more research on if I was going to use it is that number actually that radio company. So let's talk about how they reuse numbers. That's what I was alluding to a minute ago. So if it's an appliance, a 103 is made by Roper. Roper made, white goods, if you will, for your house, refrigerators and stoves and so on. In tools, Central Specialty and King Sealy. I had a King Sealy bandsaw that was a Craftsman brand years ago. Now on this list, this may be incorrect, it may be correct. We'll talk about that in a minute. But then if you look here, 108 in tools is Koval Manufacturing, and in radio, 108 is Automatic Radio. And we go up here, 103 in radio is Emerson. So you've got to know the category when you're dealing with Sears prefix codes, because they reuse them for every various commodity. So, and then we have duplications. You can see a Whirlpool here has 106, 110, and 108, and 198. And so did Air King, which is not on this list, but on the previous list. And again, this duplication may be miscategorized. I don't know if a power mower is considered a tool or if a power mower is considered lawn and garden, because none of this stuff came from Sears. So yeah, when in doubt, check it out. So here's the Stein book. Most of you have probably seen it. It's very useful to help you identify your Sears radio. But let's talk about the fact that Sears owned some of these companies. They invented this company in 1924 called King Quality Products. Then they spun it off. And by the way, they started out making cream separators. And the Sears also had a brand called Adler Royal, and because they had bought a group of stores called Adler stores. So that was probably fairly short-lived. So somewhere around the end of the 20s, Sears sold King Quality Products and purchased Colonial Radio. And then ultimately, Colonial was completely captive to Sears by 1935. However, the source code of 101 is the same for both companies. So they reused source codes because it may or may not have been the same facility. I don't know the backstory on it, but again, this, like a lot of this stuff, it's the first layer of doing the decoding. It's not the end answer. So I just want to highlight that there's two independent numbering systems. 101 on an EIA is Admiral, 101 is either Colonial or King Products. So you got to make sure you know which numbering system you're playing with. And so that covers the Sears and the EIA piece of life. I did discover while looking, this is while you're looking for something else, you find things that are useful. I found another source for brand names to companies. And that is this book by Mr. Grinder. In the back of this, he has a brand to company and a company to brand list. The however is, he doesn't make a distinction whether they're the manufacturer or the marketer. And of course, there's multiple scenarios here. So you kind of do, again, another dig down. So if it was a marketer, obviously, RH Macy sold under the Macy and the Supremacy brand. Sears sold under Sears and Silvertone and Meteor. And then you have manufacturers that did direct marketing, which we're all familiar with, whether it's RCA or Zenith or one of the big gorillas. They had it end to end. They made the thing, they sold the thing, they had the brand name. Now, obviously, they outsourced some of that stuff later on, but in their heyday, that's what they were doing. And then you'd have a private label company, which, Wells Gardner was mostly private label. Belmont did a lot. Warwick was exclusively private label. And they all made True Tone radios, which is Western Auto Supply, who is the retailer. I know it's a little bit of kind of a throw you in the water deal, but the point being is you have to peel the onion on all this stuff in order to figure it out. So to review from last time, Girardi's book, that's actually the inside page because the cover doesn't have much on it. has a list very similar to the one on the previous book, previous page. And then if you want to figure out things by their tube layout, then these Mallory Yaxley books we talked about the last time, and you can actually go online and use that to go figure out what you got. So that's what I got. And so I've opened to questions.
Thank you, Tom. That was excellent. And we now have a lot more tools than we had before to help identify what we've got in front of us.
Hey, Tom, you need to write your own book and put all this material into one location.
Yeah, I'm hoping maybe we can put this stuff up on the ARCI website at some point so people can at least know where to go look for things. But you almost need a decision tree to go through to figure this stuff out, because it ends up being multiple layers of information in order to verify you truly know who made the radio for whoever it was.
Hey, Tom, one question. Was this strictly U.S. companies, or was any foreign in there?
As far as I know, all this stuff is strictly U.S. companies. The EIA thing is I didn't see any foreign companies in there. Sears, I would guess you would find foreign companies because they obviously sourced things from other places. But whether they use that, how they cataloged it, because I gotta guess they bought TVs from Japan and so on later on. I know, most of us know that Warwick made most all their televisions towards the 60s and 70s, but I'm sure they bought stuff from Toshiba and Sharp and other people.
Okay.
Tom?
Yeah.
On Sears, I should note for you that Sears numbers, the 100, 101, etc. Sears would also produce one model radio using two different or maybe more different manufacturers. So I worked on a radio, and I've forgotten the model number, but the model number, the catalog number showed up, and I went and got a schematic for it, and the schematic was incorrect. Turned out that the schematic was for the Colonial version, and there was a Stuart Werner version, which is the one I was working on. Two different radios. The chassis were entirely different, although the case itself were identical for the two. So Sears could use different model numbers on different radios, even though they were the same.
To make sure
they were the same radio.
Yeah, make sure I got what you're telling me is that a model number 52, we'll call it, could be made by either Stuart Werner or Colonial. And so I would guess that that prefix number on the service part number would be different because it would have a different prefix.
Exactly. In the Colonial, of course, it was 101, and in the Stuart Werner, it was 100.
Yeah.
And they were distinct radios. Although the apparently Sears would give you the dimensions or the outline of how the chassis was put together, and drop it in the same case.
Would they have different chassis numbers?
Different chassis numbers. Yeah, different chassis numbers, but the same the same number in the catalog.
It's not an uncommon practice. Motorola was making cell phones for one of the Japanese phone companies, and they had a form factor that it had to look exactly like on the outside, because all the plugs had to plug in the same place, all the mounts had to be in the same place, it had to look the same. The only distinction on the outside would be a label of some kind that indicated who made it, but when you open it up inside, it could be anything it needed to be. And so it's not an uncommon practice to have, I'll call it a black box approach to a product and have multiple suppliers make the guts. It happens all the time on military electronics. Sometimes they're identical inside and just contracted out, but sometimes they're not. Thanks, Bill. That's excellent information.
Any other questions for Tom? Well, great, Tom. Thank you very much. That was excellent and really helpful stuff. That concludes our presentation part of our forum. I do want to interject at this point that we are always looking for presentations, and so you'll see a poll up there that asks you if you'd like to be a presenter. And this is what makes this forum great: is the members in the club and other clubs, they all join in. And if you need some help putting a presentation together, Matt and I can do that. We've done that a lot. And if you have some knowledge that you want to share and you want to get it preserved, this is a good opportunity to do that. So please consider that. And so with that being said, we now move to the show and tell portion. And I believe we have at least one show and tell, as indicated by an earlier poll today. So I will open it up for show and tell.
I've got a Russian transistor radio.
Oh, cool.
Thought with the topics today with the Russian radios and the transistor radios, and don't know much of anything about it, but it's a telescoping antenna. Got a room for some batteries in the back, a battery compartment. So it appears to be complete, and it's just,
that's a class 3 radio. If the model number starts with like 300, then that's a 3rd class radio, and that was the next to the cheapest radio class made in the class-free communist system. They had classes for their radios, and so that's a real cheapo Russian radio there.
okay.
It's pretty cool. Is all the lettering in Cyrillic, or is there any?
Yeah, pretty much so.
Uh-huh.
And it's got multiple bands on it, and so
Are you gonna try and repair it?
nope, it's a shelfie.
Okay.
Where did you find that, Dale?
At a Wisconsin swap meet. I had my usual variety of stuff out, and somebody came up to me and said, "You don't have one of these. You need one of these." So they dropped it off, and I kept it. So you never know. I wouldn't have brought it, but it's like Keith said, you never know.
Yeah, that could have been the same Wisconsin swap meet that Keith saw the thermoelectric generator.
No, I don't think so.
Any more show and tells? Anybody have anything they want to share?
I talked about the Magnavox AW100, their transoceanic type radio. You can see it wasn't a particularly sexy looking cabinet design, but wow, what a performer. And the advantage this had over the transoceanic, besides being a hotter performer, was continuous coverage from the bottom of broadcast band all the way up to 22 megacycles. It didn't have the gaps with the band spread tuning, and a real hot performing radio. So for any of you guys that want a really great DX radio, keep your eyes out for one of these. Beautifully built, although the cabinet was nothing to brag about. I want to show the electronics real quick here.
I have that in a blue. Pebble
In blue?
Yeah.
Really?
And
I've never seen the blue one.
I also have they had a travel case for it. It's a hard.
Which I have.
Oh, okay. You have the travel case.
I do. There we go.
What's the model number again?
AW100. And you can see all hand wired, beautiful chassis. They went to a lot of extra to really make this radio really nice. The engineers at Magnavox at that point in time, Transistor was new, and those guys did one heck of a job when they came out with that radio. Why they decided to abandon transistor radios as early as they did was beyond me, because they had great product. But I guess they just figured they could make more profit off having NEC build it for them.
Who's the manufacturer again?
That was Magnavox, and they actually made those in Fort Wayne, Indiana.
An AW 1000.
AW100. It's called the AW100 Intercontinental.
All right. Thank you.
And a truly great radio, and very serviceable, by the way.
Thank everyone again for participating today, and hope you can be a presenter in the futures. And we'll see you next time.